In this next case, you've been told to determine the stationary values of z is equal to x cubed minus 6xy plus y cubed. In that case, what does it imply? It implies you only determine the stationary values only. You don't classify them by stating their nature, isn't it? So you only determine the stationary values. So when you are determining the stationary values, you know that at the stationary point, the derivative is 0, isn't it? So you come at the stationary point. At the stationary point. Remember, we are saying at the stationary point, not at the turning point. Because the stationary point will either be a turning point or a shadow point, isn't it? Because you don't classify the stationary point, you don't know whether it's a turning point or a shadow point. So don't come and say at the turning point. You don't know the nature of that stationary point. Are we together? So at the stationary point, the derivative is 0. Because we are dealing with partial derivatives, then it means the partial derivative with respect to x is 0, or partial derivative with respect to y is 0. Because we have it z is a function of x and y, isn't it? Because z is in terms of x and y. It is a function of x and... Are we together? So let us start. If we differentiate partially with respect to x, it means only x is considered as a variable. Anything else is a constant, isn't it? So you come here, x cubed. If you differentiate x cubed, you get 3x squared, isn't it? Yes, 3 times 1 is 3, you reduce the power by 1, isn't it? Then if you look at this, only x is a variable, meaning this negative 6y is a constant, isn't it? So negative 6y, you put outside as a constant, then this x is what we're differentiating, isn't it? If you differentiate x, you get? So what do you remain with? Negative 6y. Then if you differentiate y cubed partially with respect to x, 0. Meaning the whole of this y cubed is 0. There is no x here. Only x is a variable. Are we together? Then the next one, we now want to do it partially with respect to y, isn't it? So when we are differentiating this function partially with respect to y, because we are saying z is a function of xy, so that's why we're using f after stating this, isn't it? Are we together? Yes. If you did not state this, you would have used those notations, partial z, partially with respect to x like that, isn't it? Are we together? Yes, which is the same as f subscript x, or partial z, partially with respect to y, which is the same as f partial subscript y, isn't it? Are we together? So if we are differentiating partially with respect to y, it means only y is a variable. Is that okay? So x cubed, there's no y here, meaning the whole of this is a constant. So if you differentiate a constant, you get 0. Only y is a variable, meaning minus 6x is a constant, isn't it? So if you differentiate y, you get? So what do you remain with? Negative 6x, isn't it? Then you go, if you differentiate y cubed partially with respect to y cubed is a variable, isn't it? What do you get with the derivative 3? 3y squared if you differentiate y cubed. Are we together? So it means at the stationary point, either this is 0 or this is 0. Are we together? So we have simultaneous equations. The first one we have 3x squared minus 6y is equals to 0. The second one we have minus 6x plus 3y squared is equals to 0. Now look here, the first thing you have to write them in their simplest form before you check the appropriate method, isn't it? Are we together? Simplest form, look at this first one. See, 3 is a common factor here. So you divide all 2 by 3. Isn't it? So 3 divided by 3 and you remain with x. Negative 6 divided by 3, you remain with negative 2y. 0 divided by 3, you remain with 0, isn't it? And simplify this second one. See, 3 is a common factor. Isn't it? I divide everything with 3. This one divided by 3, you get negative 2x plus 0 divided by 3 is 0, isn't it? See, the appropriate method here is substitution or elimination, whichever you choose, isn't it? See, this is equation 1, this is equation 2. In equation 1, it is easier to make y the subject of the formula, isn't it? So in equation 1, you have x squared is equal to minus 2y going the other side. You get 2y, isn't it? So there you have x squared is equal to 2y. So if you divide both sides by 2, what do you get to be y? If you divide both sides squared by 2, you get y to be x squared over 2. Severe. So from this first equation, we are able to get y to be x squared over 2. Meaning, in the second equation where we see y, we put what? X squared over 2, isn't it? In the second equation, we have minus 2x plus y squared. Meaning the value of y must be inside the bracket because the whole of it is the value of y, isn't it? So it is minus 2x plus y squared. But your y is what? Y is? Y you found is x squared over 2 from the first equation, isn't it? To be equals to 0. The next step is just to open the bracket, isn't it? Next step is to open the bracket. So start minus 2x plus I. Meaning this square outside squares everything inside the bracket. Lots of this is because we only have division inside, isn't it? So x squared squared, what do you get? X to power 4. A power outside multiplies the power inside. Lots of indices. Are we together? That is x to power 4 over 2 squared is equals to 0. So if you open that bracket, you get that, isn't it? So what is the next thing? So you get rid of the denominator. Meaning you multiply both sides of the equation by 4, isn't it? So if you multiply both sides of the equation by 4, what do you have? Negative 8x. X raised to power 4 is equals to 0. What do you see here? So you can rearrange this so that you have x raised to power 4 minus 8x is equals to, isn't it? So you can see x is a common factor. You can factorize out a common. So if you factorize x outside, you get x into x raised to power 3 minus 8 is equals to. Now, if you have a product of two factors to be 0, what does that imply? It implies either the first factor is 0 or the second factor is 0. So this implies that either x is 0 or x cubed minus 8 is 0, isn't it? Are we together? So what do you get? It means x is 0 or x is equals to, meaning negative 8 going the other side, it becomes positive 8. So for you to get x, you find the cube root on both sides, isn't it? So that cube root of 8 is, are we together? We found the two values of x. After getting those two values of x, so we found x is equals to 0. When x is 0, what is y? Y is supposed to be what? X squared over 2. So it means y is 0, meaning where there is x, you put 0. Are we together? So when x is 0, y is 0, this implies that this point is in the form xy. So the first stationary point is 0, 0. Are we together? Then you move to the next one. When x is equals to 2, you come again. That one was implying that. When x is equals to 2, what is its coordinate? Y. Where there is x, you put 2, because we know y is x squared over 2. That is what we were using, isn't it? So x is what? So it means it is 2 squared over 2. What do you get to be y? Y is 2. So from here it implies our point xy. So this is x1, y1, you can say this is x2, y2, isn't it? Is what? X is 2, y is 2. And we've determined the stationary points. In this case, we've not been told to classify them by stating their nature. We only want to determine them only, isn't it? So we've determined the two stationary points. Are we together? Good. So that is how to deal with that case.